friends, welcome back to our channel. So in the previous session we have seen the iterative statements and the conditional statements. So we have covered the control structures. Now in this session we'll see the arrays concept. So far we have seen a variable which can hold only one value, but here the array can hold multiple values. Of same data type. So these arrays can hold multiple values of same data type. So if you declare an array as integer, so it can hold completely integer data types. And if you declare an array with a character, so all the elements should be of character data type. If you declare an array using float, all the elements should be of a float data type, right? So here array is represented in terms of subscripts. So how many dimensions we can use? So this is called, if only one subscript is used, that is nothing but one dimensional array. And if you are using the two subscripts, it is a two-dimensional array, right? So this subscript should be placed after the variable name. Let it be some a. So this is called an array. This is a one-dimensional array as we are including only one subscript, and this is a two-dimensional array as we are using the two subscripts. And in between these subscripts, we have to mention the size of the array. So in between the subscripts we have to mention the size of the array. So we have to give a maximum size at the declaration part itself. So let it be int a of 10. So that this statement includes, we are declaring an array a which can hold a maximum of 10 elements. So it doesn't imply we should use all the 10 elements. It implies it can hold a maximum of 10 elements. Depends upon our logic, we can use the elements in between 0 to 10. Right. Now the syntax for this declaration is the data type, array name, followed by the subscript. Inside the subscript we have to mention the size. So compulsory we have to mention the size at the declaration part. So without mentioning the size we'll get an error, right? So the maximum size we have to mention in the declaration. Now we'll see the one-dimensional array in this session. In the next session we'll go with the two-dimensional array. See. One D array. So it is having only one subscript. And all the memory locations, all the elements of this array will be stored in continuous memory locations. So elements occupy continuous memory locations, right? So that implies, so if the base address is 1000, if the base address is 1000, the elements of an array, the first address is 1000, the second address will be 1002 if it is a integer of 16-bit compiler, because integer occupies 16-bit compiler. If it is a 16-bit compiler, the integer will occupy 2 bytes of data. So 1002, 1004, 1006, right? So this is the first element, second element, third element, and the fourth element, right? So elements will occupy the continuous memory locations in this one-dimensional array. And the applications where we can use these one-dimensional arrays are searching techniques and sorting techniques. The best example for these one-dimensional arrays are searching and sorting techniques. So in order to implement these searching and sorting techniques, we'll go with the one-dimensional arrays. Now, how to declare and how to initialize the one-dimensional array. So declaration, so int a of some 20. So this is the declaration and initialization, sorry, declaration but not initialization. So directly we can initialize at compile time simply by placing the elements in curly braces. So this is a compile time initialization. Now this statement implies array A which can hold a maximum of 20 elements where the elements are 1, 2, 3, 4 and 5. So here we are initializing only 5 elements. It occupies the index values from 0 to 4, and what about the remaining 15 elements? So all the remaining 15 elements will become 0, right? So unless you initialize at least one element, all the remaining elements will becomes 0. By default it will be 0, right? So here the index values. So how can we access all these elements? These elements can be accessed with the index values. Elements can be accessed using index values. So these index values will start from 0. So all the index values will start from 0, right? See. So this is a compile time initialization. During the program itself we can initialize the values. So this is called a compile time initialization. So other than this compile time initialization, at the runtime also we can read the elements into an array. So for that we have to read all the 20 elements. If you want to read all the 20 elements, we have to use the iterative statements, right? So it is not possible to write all the 20 cin statements. So we know that cin is nothing but the input statements. So in order rather than using the 20 cin statements, we can go with the iterative statements. You can use the iterative statements either for, while or do while in order to read the elements into an array. So for that, see, for I is equal to 0 because index value starts from 0, I less than the size, so whatever the size it may be, I plus plus. Here you can write cin a of I. See, if you write this one, so first I is equal to 0, 0 less than size, so let it be some 10. So 0 less than 10, true, the control will enter into the loop cin a of 0. So whatever the element we are reading from the keyboard, that will be saved in a of 0. Right? So here also, see, a of 0 will be 1, a of 1 will be 2, a of 2 will be 3, a of 4 will be, sorry, a of 3 will be 4, and a of 4 will be 5. So total 5 elements. So these elements will be accessed with the help of index values. So similar way, we can read all the elements at the runtime with the help of these iterative statements, right? So I will explain you this practical implementation in the compiler itself, right? So we'll read the number of elements into a single dimensional array, and also we will display the elements on the screen, right? So we'll see the practical part. So the main application is for searching and sorting applications. We'll go with this one-dimensional arrays. So based upon the subscript using, we can identify whether it is a single dimensional array or a double dimensional array, 1D or 2D arrays, right? So hope you understood this one. So how to initialize, declare and initialize at the compile time, and how to initialize at the runtime, right? So now we'll move on to the compiler and I will show you the implementation part. So how actually the one-dimensional array works. So reading the elements into an array and displaying the elements from the array. Right. Let us move on to the compiler. Hello friends. Just now I have seen the theoretical part of one-dimensional array. Now we'll see the practical implementation. Right. So first let us, the main applications of these one-dimensional arrays is, these arrays will be used in searching and sorting techniques, and all the memory locations, I mean the memory will be occupied in continuous memory locations, right? So first we will include the header files. So include io.iostream.h, similarly hash include conio.h. Right. So let us create a main function. Now we can declare the loop variable n number of elements and one array. We have to mention the size, the maximum number of elements that the array can occupy. So I am specifying the 10. So we need not use all the 10 elements. So here a of 10 means a is declared as an array which can hold a maximum of 10 elements. So depends upon our logic, we can use the number of elements inside the program. Right. Now, so I will write the clr str function to clear all the previous outputs, and now just we'll read the value. So how many elements to be taken? Enter the number of elements. So here we can read the number of elements. So C in n. Now, so we can read n number of elements now. So for that we can use the iterative statements in order to read all the elements at the runtime. So for I is equal to 0 because index starts from 0. I less than n, I plus plus. So here you can use scene a of I. So here we will write one more out function. So enter the elements to an array. Right. Now, so these statements will read the elements into an array. Now what about the display? Again use the same iterative statement, same logic for reading. Instead of input function we have to write the output function so that the elements will be displayed on the output screen. So cout a of I. Right. So here we again we will write cout elements of an array. Right. Now let us close this one and let us save this one. Array.cpp. Now let us compile this one and we'll execute this one. So it is asking about the number of elements to be read. So I am giving a 5 elements. So enter the elements to an array. So 10, 20, 30, 40 and a 50. Now let us check the output. See. So you can observe elements of an array 10, 20, 30, 40, 50, but everything are repeated in a single line, whereas if you use this NL, so every time it will be displayed on the next line. So let us execute one more time. So 5 elements, so 10, 20, 30, 40, 50. Now let us see the output. So you can observe elements of an array 10, 20, 30, 40 and 50. So as it is a single dimensional array, the memory allocations occupied in continuous memory addresses.
Let us stop here. So if you are having any doubts regarding this one-dimensional array, feel free to post your doubts in the comment section so that I will definitely try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.